Okay, so this is 6.2, part 2. Broke this lesson down into 3 separate parts. Unit circle, 6.1, where we're just figuring out what cast is all about, and now this part where we're looking at answering questions about the different trigonometric ratios in all 4 quadrants. Okay, so for any angle theta in standard position between 0 and 360 degrees with terminal point P with xy, the primary trigonometric ratios are defined as, well, you can look at it this way, right? We can find cos theta as being equal to x divided by r. Sine theta is going to be equal to the value of y divided by r, and we know that because this is in standard position with a unit circle, the r's are equal to 1, and tan theta is going to be equal to y divided by x, where, take that theta out there, and I don't know why it's there, this is just Pythagoras. R is going to be equal to the value of x squared, the square root of x squared plus y squared. So here the primary trigonometric ratios of an angle in quadrants 2, 3, or 4 are related to the trigonometric ratios of the reference angle in quadrant 1. Okay, so we're always looking for the reference angle. So the point B, -2, -4, and the terminal arm of angle theta in standard position, what are the primary trigonometric ratios of theta? Determine the measure of theta to the nearest degree. Okay, so I'm going to pull down the screen a little bit so I have a little bit of writing room. There we go. Okay, so to understand this a little bit better, maybe the first thing we want to do is just draw a little plane and what's going on here. So let's draw a little Cartesian plane here. We know that this is -2, -4, so we have a line that looks like this. Let's connect this up like so. Drop that perpendicular down to the x-axis. Yeah, definitely not drawn to scale. We know that this value is 2. Actually, -2. This value is -4. And we have this r value here. Theta is what we're looking for here. So here we have this point. -2, -4. Okay, so to figure out what this r value is, we're just going to use Pythagoras. R is going to be equal to the square root of -2 squared plus -4 squared. So that's going to be equal to the root of 20. But we'll use this as an exact value. The biggest perfect square factor that goes into 20 is 4. So we're going to express this as 2 root 5. Okay, so our r value here is going to be equal to 2 root 5. So now we can express the trig ratios. So sine theta is going to be equal to -4 over 2 root 5. But these can both be divided by 2, so it's -2 over root 5. Cos theta is going to be equal to -2 over 2 root 5, but we can divide it both by 2, so that's -1 over root 5. And tan theta is going to be equal to -4 divided by -2, which is equal to +2. Now you notice of the 3, the tangent is the only one that's positive. So when we're calculating the angle for B, we want to use the positive ratio. So we're just going to do inverse tan 2. Make sure your calculator is set on degrees. That's going to give you 63 degrees. So this reference angle here is equal to 63 degrees. So to calculate what the actual angle is, all we'll do is we'll add 180 plus 63 degrees, which gives you 243 degrees. Okay. Do the check. The full solution is in your book, and the angle at the end should be 292 degrees. Okay, moving on to example 2 now. What happens when you get a number like this to the nearest degree? Which values of theta satisfy the equation tan theta is equal to -4/3 for all 4 quadrants? Okay, so for this one, what we're going to be doing is taking a look at calculating it. Okay, so when we calculate it, we want to be thinking of cast here, right? And that'll tell us where what regions we'll be answering in. Okay, so if you remember from CAST last time, a little memory device, CAST. Cosine's positive here. All the trig ratios are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. For this tangent to be negative, it must mean that my answer is going to be in quadrant 2 and quadrant 4. Okay, so from this we see that there are two possible solutions. So we know that two solutions to the equation. So the first thing we're going to do here is find the reference angle. Now you'll notice that although this does say tan theta is equal to negative 4/3, when I do the inverse tan, I'm just going to use the positive value only. So we're going to ignore the negative sign, because when you do that, then it gives us what the reference angle is. So we know that our reference angle is going to be equal to 53 degrees. So that's not the answer. That would be the answer for us in quadrant 1, but we're actually in 2 and 4. So in quadrant 2, it's going to be equal to 180. Can you see it here in quadrant 2? Minus 53 degrees. So you subtract out the reference angle. That's going to give you 127 degrees. In quadrant 4, it's going to be equal to 360 degrees minus 53 degrees, and that's going to give you 307 degrees. Okay. Turn to page 183 and try the check. The full solution for this problem is on page 446. Okay, now in the last example for this question, it now has the cosine ratio, and you're supposed to determine all the other trigonometric ratios of the angle alpha, and to the nearest degree calculate other possible values of alpha when we're going between 0 and 360. Okay, so for A, let's let P, point P, we'll let it be a terminal point. Okay, so that means here we've gotten some information that cos alpha is equal to negative 4 over 5. Remember, the ratio is always going to be positive, so that means the x value is negative 4 and the r is equal to positive 5. So we know that from here we see that the x is negative. So in order for the x to be negative, it must be in quadrants 2 and 3. So the solution is in quadrants 2 and quadrant 3. Okay, so we'll use this. R squared is equal to the x squared plus y squared. So r is 5. We know that x is negative 4. So that's 25 minus 16 is 9. So my y must be equal to 3. Once I have the y, I can start calculating what the ratios are in the other areas. So in quadrant 2, we can say that the sine of alpha, now that we have y, is going to be equal to 3 over 5. And we know that tan alpha is going to be equal to 3 over negative 4. When we're talking about quadrant 3, we now go there, and now my y value becomes a negative, right? So sine alpha is equal to negative 3 over 5, and tan alpha is equal to negative 3 over negative 4, and negative divided by negative gives you positive. It's actually positive 3/4. For part B, I'll kind of squeeze over here, possible values of alpha. So we're going to calculate the reference angle. So we're going to go inverse tan positive 3/4, and that's going to give us a reference angle of 36.8698 degrees. So we'll just round it off to 37. So quadrant 2, when you picture this in your head, it's going to be 180 minus 37 degrees. That's going to give us 143 degrees. And then in quadrant 3, it's simply 180 plus 37 degrees, and that's going to give us 217 degrees. Try the check. Remember, to get full marks on the assessment, you have to have the checks done as well. If you get stuck, it's on page 447.